Alcohols can be dehydrated to form ethene and steam in the presence of a catalyst. The forward reaction is endothermic, so let's just write that on there straight away. Endothermic. What am I writing XO for? Endothermic. Explain how the conditions should be changed to maximise the yield of ethene. Okay, this is a reversible reaction, and we can tilt the position of the equilibrium by playing with some conditions. The conditions we can mess with are going to be temperature, pressure, and if it were solutions, concentration of solution, but this isn't in this case because these are all gases. So pressure if it's gases, of course. So temperature to start with. Right, if you want a good grade on GCSE chemistry, or indeed double awards science, and you're going to do the higher tier, you just need to get used to answering these questions. They're so ridiculously common. Okay, so the first thing you need to remember is this rule about temperature. So the rule about temperature is as follows. Increasing the temperature always favours the endothermic reaction. So if you get a question like this where they're asking you how we're going to maximise the yield or ensure we get the most amount of product produced, and we've got a reversible reaction, just write this out just like that. You'll get a mark straight away. Now we need a second mark for applying it. Now in this case, the forward reaction is endothermic, so increasing the temperature favours the endothermic, and we want to favour the endothermic reaction. So because the forward reaction is endothermic, we now need to write here high temperature should be used. If the forward reaction were exothermic, would say low temperature, because that would increase the yield. But high temperature should be used. And that's explain the temperature thing straight away. So learn the rule, apply it. That's how we do these. So that's the temperature explained. Next condition we need to explain is pressure. This is a tiny bit more complicated. Okay, to do pressure, the first thing we have to do is count gas molecules. So on the left-hand side of this reaction, now to count gas molecules, we're interested in the stoichiometry of the equation. Now there's no number before the ethanol. This is the alcohol here. There's no number before it, so there is a 1. On the right-hand side, there's no number before the ethene, so there is a 1. There's no number before the water. Now this is gas water, so that's a gas as well. So 1 water. So on the left-hand side, there is 1 molecule. We count the stoichiometry to work out how many molecules we've got. We've got 1 molecule on the left. On the right of the arrow, we've got 1 plus 1, 2 molecules. Okay, so to work out how pressure affects the position of equilibrium, we need to count molecules. That's always the stoichiometry numbers before the gases in the equation. The left-hand side, 1 molecule. Right-hand side, 2 molecules. Now, what's the rule we have to learn here? This was the rule we had to learn for temperature. Okay, what's the rule you've got to learn for pressure? The rule for pressure is increasing the pressure favours the side with the fewer molecules. So which side's got the fewer molecules? Answer left-hand side. So in other words, if we do this at a high pressure, we're going to push the reaction this way, towards the left, towards the reactants. That's not what we want. We want to favour the side with the products. So if increasing the pressure pushes it to the left, reducing the pressure would push it to the right. So low pressure should be used. All these questions and more on elshamhighchemistry.com.